Lewis structure. Lewis dot symbols. The valence electrons of main group elements are represented as dots or cross sign surrounding the symbol of the element. For example, lithium, it has only one valence electron. So one dot symbol means this lithium has one valence electron. Beryllium, two valence electrons. And make sure that the position of these two electrons are far from each other, because electron and electron repel because they have the same charge. And for the third one, boron have three valence electrons, so these three electrons are far from each other. Same goes to carbon, four valence electrons. There are four positions to put the valence electron: on the left side, on the right side, on the upper side, and on bottom side. So these are the four positions that you can put the electrons. You can't put the electron in the corner. That's how you draw the Lewis dot symbol. Shows the valence electrons of the main group elements. Octet rule. Explaining, an atom tends to form bonds by losing or gaining or sharing electron other than hydrogen, because hydrogen follow duplet rule, until it is surrounded by 8 valence electron. Magnesium, which has 2 valence electron, transfer its 2 electrons to sulfur, which has 6 valence electron, making the magnesium ion losing 2 electron, Mg2+, and sulfur receive 2 electrons, S2-. They combine together in ionic bond to become magnesium sulfate. This is an example of transfer of electrons. And the example for sharing of electrons, usually in covalent bond. This shows 2 fluorine atoms having 7 valence electrons each, sharing 2 electrons for them to follow octet rules. So both of them are surrounded by 8 valence electrons while they are sharing the electrons. Type of stability of ions. 3 types of stability of ions: noble gas configuration, pseudo-noble gas configuration, and half-filled orbitals. For noble gas configuration, atom forms stable ion with octet or duplet configuration. Pseudo-noble gas configuration, all their orbitals are completely filled with electrons. So it's not necessary to follow the octet rule. As long as all their orbitals are completely filled with electrons, they are called pseudo-noble gas configuration. Half-filled orbitals, electron configuration associated with half-filled d orbital. For example, d5 orbital. So completely filled, d10. If half-filled, 5 electrons are in d orbital. Noble gas configuration, atom forms stable ion with octet or duplet configuration. Means the valence electrons are 8 or 2. So this sodium atom has 1 valence electron, then it loses 1 electron to become Na+. The valence electron of Na+ are 8 valence electron. So neon has electronic configuration of 1s2 2s2 2p6. So that's why 1s2 2s2 2p6 is equivalent to the electronic configuration of neon. That's the electronic configuration for Na+ as well. Next, chlorine with 7 valence electron receive 1 electron to follow the noble gas configuration, because it has this chlorine ion has octet configuration, 3s2 3p6, 8 valence electron in total. 1s2 2s2 2p6 3s2 3p6 is the electronic configuration for argon. So chlorine ion has the same electronic configuration for argon. This is what we call noble gas configuration. Pseudo-noble gas configuration, all their orbitals are completely filled with electrons, but electronic configuration is not that of any noble gas. The valence electron configuration is ns2, np6, and d10. All the orbitals are completely filled with electron, it's not necessary to follow the octet electron arrangement or duplet electron arrangement. For example, zinc atom, it has until 4s2, and if it becomes zinc ion, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So this is pseudo-noble gas configuration. Valence electron is ns2, np6, and d10. These are the pseudo-noble gas configuration. Half-filled orbitals, usually for d orbital, half-filled d orbital. The Mn atom has the electronic configuration till 3d54s2, and for Mn become Mn2 plus, it will have until 3d5 because you remove 2 electron from 4s, so it will become until 3d5. So this is half-filled orbitals. Chemical bonding. There are 3 types of chemical bonding for your syllabus: ionic bond, covalent bond, and metallic bond. Ionic bond, attractive electrostatic force between positive and negative ions. So you have positive ion and you have negative ion. They are attracted together by the electrostatic force. It is also known as electrovalent bond, not covalent, electrovalent bond, formed when metal combined with non-metal by electron transfer. So that's ionic bond. You transfer the electron, not sharing the electron. If that is the transfer of electron and there are the electrostatic force between positive and negative ions, it will become ionic bond. For covalent bond, electrons are shared between non-metal atoms. So both have to be non-metals to form covalent bond. Electrostatic forces between shared electron. This is different from ionic. Ionic happen when you have electron transfer, but covalent bond, it's between shared electron, not transferring, it's sharing the electron. With the nucleus of both shared atom will form a covalent bond. For metallic bond, electrostatic attraction between positively charged metal ions and sea of delocalized valence electron. We'll see more at the end of chapter 4 on metallic bond. The electron sea model is used to explain the metallic bond axis in metallic elements. For ionic bond, sodium atoms transfer their valence electrons to oxygen and form sodium ion. So this sodium atom has 1 valence electron only, and oxygen has 6 valence electron. For the sodium to achieve octet configuration, it has to lose 1 electron. It needs to transfer 1 electron. For oxygen to achieve octet electronic configuration, it has to receive 2 electrons. So this oxygen needs 2 sodium atoms to get 2 valence electron. So 2 Na plus will combine with 1 O2 minus ion by electrostatic force, and this is ionic bond. Oxygen accept electron from 2 Na plus and form oxide ion. The electrostatic forces between 2 Na plus and 1 O2 minus forms ionic bond. For covalent bond, the keyword is sharing electron. Again, they are formed when non-metal atoms combine. Fluorine non-metal atom combined with another fluorine non-metal atoms by sharing the electron. These 2 electrons, so for one fluorine atom has 7 valence electron and another one fluorine atom has 7 valence electron. Each of fluorine atom share 1 of their electron, so resulting 2 electrons in the middle, so they are sharing 2 electrons in the middle. The shared electrons are counted as octet or duplet of both atoms and considered to be localized. The oxygen atom sharing 4 electrons because this is double bond. 1 bond means 2 electrons, so when you have double bond or 2 bonds, they are sharing 4 electrons in total. So 4 electron sharings in total and 4 electrons at each atom will result in octet. Coordinate covalent bond or dative bond. Coordinate covalent bond or dative bond form when one of the atom donates both electrons. So this is not ionic because two nonmetals are combined. Even though there is a transfer of electron in dative bond, there is transfer of electron. This is not ionic because ionic form from one metal atom and another non-metal atom. But here, both are non-metal atom combined. So it is dative bond or coordinate covalent bond, also called covalent dative bond. So this N atom bonded with other 3 hydrogen has 2 lone pair of electron. So this 2 lone pair of electron is donates to H plus, and then one bond will form. So it will become NH4 plus. This is the example of dative bond. Steps in drawing Lewis structure. This is for covalent molecule. The first step, you have to count the total number of valence electron of that atom. Second step, draw the skeletal structure of the compound. Next, count the remaining electron left from the valence electron. And the final step is to complete an octet, 8 electron, for all atoms except hydrogen. Hydrogen, you need to complete 2 electron because it's 2 plat. Okay, step number 1. For example, NF3. We need to draw the Lewis structure for NF3. The first step, you have to count the total number of valence electron, not the total number of electron of NF3, just the total of valence electron. You have to add electron if this is negative charge ion, but subtract the electron if this is positive charge ion. But our NF3 is a neutral compound, so you don't need to add or subtract, just count the total number of valence electron of NF3. For N, you only have one N in NF3, so N times 1. The valence electron of N is 5 electron, so 5 times 1, 5 electron in total. Fluorine valence electron 7, you have 3 fluorine, so 7 times 3, 21. The total number of valence electron in NF3 is 26 electron in total. That's the first step. For the second step, draw skeletal structure of the compound showing the atoms bonded in the molecule. So now we know we have NF3. You have to choose which atom need to be at the center. The atom that needs to be at the center is the atom that has least electronegative. N, group 15, F, group 17. Across a period, the electronegativity increase, so group 17 has higher electronegativity than group 15. Thus, this fluorine is more electronegative than nitrogen. The one or the atom that needs to be at the center is the atom that has least electronegativity. So N, which has least electronegative, must be at the center. So that's why you put N at the center, bonded to other 3 fluorine atom as the surrounding atom. That's how you determine which atom has to be at the center of the compound. Step number 3. Count the remaining electron left from the valence electron. Now we have the total number of valence electron from step 1, 26 electron. And then count the number of electron which is used to form the covalent bond. Step 2, you draw the skeletal structure of NR3. So this N has bonded to 3 fluorine atoms, 1, 2, 3. One bond means 2 electrons. When you have 3 bonds, means you have used 6 electrons in bonding. So the total number of valence electron minus 6 electron, the number of electrons used to form covalent bond. Step number 3 is you have to count the remaining electron left after you use it for covalent bond. So the remaining electrons are 20 electrons. For that 20 electrons, use that electron to complete an octet, 8 electrons for all atoms except H. So you have to put that electron at the surrounding atom first before you focus on the center of the atom. Put all the 20 electrons at the surrounding atom first before placing the remaining at the central atom. Now we have 20 electrons remaining. Put until all the surrounding achieve octet. Now this fluorine bond have 2 electrons, so you have to put 6 more to become 8 electrons, and 6 more to become 8 electrons, 6 more here to become 8 electrons. Now you have used 6, 6, 6, you've used 18 electrons. For the surrounding atom, you have used 20 minus 18, you have 2 electrons remaining. And then these 2 electrons you can put at the central atom. The remaining put at the central atom. Now you can see this nitrogen has 8 valence electron. 2, 4, 6, 8 valence electron. So that's 2 electron number of lone pairs electron. These are lone pairs for central atom. Lone pairs for fluorine, 6. Lone pairs for central atom, 2 electron. These are bonding pair. The one that you use for bonding, you call bonding pair. The one that you use for completing without bonding with any atom, you call it lone pair. Next example, CO3 2 minus. So this is the negatively charged compound. The first step, count the total number of valence electron. When the compound is negatively charged, you have to add electron. So it's 2 negative, so you have to add 2 electron. First, count the total valence for CO3. Only 1 carbon. 1 carbon has 4 valence electron. 4 times 1 because you only use 1 carbon, so 4 electron. Oxygen, we have 3 oxygen. Valence electron of oxygen is 6 electron. So 6 times 3 because you have 3 oxygen. 18 electron for oxygen in total, so you have to add 2 more electron because the charge is 2 negative. So 18 plus 4 plus 2, you have 24 electron in total for valence electron CO3 2 minus. That's the total number of valence electron. Step number 2, draw the skeletal structure and then choose which is the least electronegative. It has to be the center. So this carbon is in group 14, oxygen group 16. Group 16 has high electronegativity compared to group 14. So this carbon is least electronegative, so it has to be at the center, and the oxygen will be the surrounding atoms. And for you to bond the carbon with oxygen, you have to use 3 bond, 1, 2, 3, and this 3 bond is the total of 6 electron. So you have used 6 electron for bonding. Okay, we've used 6 electron for bonding, and make sure if the compound has charge, you have to put in bracket and you have to put that charge for that Lewis structure. For this one, you don't have to put bracket because it is neutral compound, it doesn't have charge. But for this one, you have to put in bracket and the charge of it. Okay, second step, draw skeletal structure. So you use 6 electron for bonding. The third step, count the remaining electron. Total valence 24 electron, and the electron you use for bonding 6 electrons. So 24 minus 6, leaving us with 18 remaining electron. That 18 remaining electron you have to use to complete an octet, 8 electron for all atoms except hydrogen, triplet. So that 18, you have to complete that octet for surrounding atoms first. Our surrounding atoms are oxygen, so put the 18 electron to all surrounding atoms. Make sure each atom achieve octet electron arrangement. So this oxygen initially has 2 electrons only, and you have to put remaining 6 times 3, and you use 18 electron. 18 minus 18, remaining 0 electron. But all electrons have been used for the oxygen. Our problem is the carbon has 6 valence electron. It still has not achieved the octet, but we have no electron left. If the central atom is not octet yet, make a multiple bond by using a lone pair from the surrounding atom. So our oxygen, we have 6 lone pair of electron, 6 lone pair electron, 6 lone pair electron, 6 lone pair electron. This electron, we call it bonding pair. The electron that we use for bonding, we call it bonding pair. The electron that is not involved in bonding, we call it lone pair. So if your central atom is not octet yet, use the lone pair at the surrounding atom for bonding pair. So for example, we use this 2 electron to make it a bond, and it will become like this. Okay, you make multiple bond. So now your carbon has total valence of 8 electron, and if you check, your oxygen also have total valence of 8 electron. That's the final step. If your central atom has not achieved octet, make multiple bond. Make sure you use the electron at the surrounding atom.